So our next topic is future value annuity. We have covered future value simple interest, compounding interest. Today we'll be continuing with annuity, both ordinary annuity and annuity due, that is payments made at the end of time period and at the beginning of time period. This is the formula for ordinary annuity. That means you're making the payments at the end of each time period. For example, if I'm having an investment plan of, let's say, for 4 months, right? Jan, Feb, March, April, I'll be making the payments Jan 31st, Feb 28, March 31st and April 30. Okay, so these are the days I'm going to make the payments. On the opposite, what is annuity due or payments made at the beginning of each year? It's going to be Jan 1st, Feb 1st, March 1st and April 1st. Okay, now here we're going to look at the amount even cash flows of annuity. What is an even cash flow? Even cash flow is the same amount of money that you're paying at equal intervals of time. What is uneven cash flows? You are paying different amount of money at equal intervals of time. Here we have rupees 100. Question number 8. Annuity is rupees 100. Compounding rate is at 10% and the number of years is 4 years. Now here if we can look at the payments are made at the end. The question clearly mentions. So interest will be given 100 rupees for the whole period. For the second payment for the whole period. For the third payment for the whole period. For the fourth payment, please notice, for the fourth payment, you will not receive the interest if you are paying the annuity at the end. Reason being, if you can see the formula, first annuity you're calculating interest, second annuity you're calculating interest, third annuity interest is calculated, but fourth annuity interest is not calculated. Reason being, on the date where the investment is maturing, even your last annuity payment date is going to be the same. I repeat, your last annuity payment date as well as the investment maturity date is both clashing here. Therefore, the bank or any institution is not going to pay for the last installment because at that date, particular date, your investment will be maturing. So therefore, whatever 100 rupees you're giving on the last date will return back to you as it is as annuity. No interest will be added to it. Let's solve this question. A is 100, 1 plus 0.1 to the power of n is 4, 4 minus 1, 100, 1 plus 0.1 to the power of 4 minus 2, 100, 1.01 to the power of 1 plus 0.1 to the power of 4.3 and then we have 100. Further classified 100, 1.1 to the power of 4 minus 1 is 3, 100, 1.1, 4 minus 2 is 2, 100, 1.1, 4 minus 3 is 1 and then the last one is only 100. To the power of 3 is 1.12. Anything to the power of 1 is 1.1 itself and 100. So it's going to be 133 rupees, 121 rupees, 110 and 100. So in total you will be getting 464 rupees. So if you're going to start investing now 100 rupees at the end of each year, after 4 years you'll be having a total amount in hand that you'll be getting is 464 rupees. So there's an alternate method how to solve the same question in a table format instead of a formula format. So I want you to just create 4 columns over here. The first column says year, second is the annuity, whatever is given in the question, and the next one is your interest rate at the rate of 10%, and the last one is your future value of annuity table. So remember, whenever writing your interest rate, always make sure you're writing 1 plus the interest rate, because while writing the formula you can add 1, the constant, to every interest and annuity calculation. But since we are doing in the table, let's put it in the formula itself. So it says 1 plus 10% divided by 100. That means to say 1 plus 0.1 gives you 1.1 at the year of 1, and then at the year of second to the power of 2 will give you 1.21, to the power of 3 will give you 1.331. So I told the last year you won't have interest as you're paying in the end. So just as the 100 rupees annuity you will be paying, you'll be receiving back. So give a number to each column. Column number 1, 2, 3 and 4. So how do you find out the future value of annuity is? Fourth column equals to your second column multiplied by your third column. So once you multiply and get your answers, just total it up, you will still end up at the same answer. 464 rupees is your future value if you start investing from now, 100 rupees each. So let's move to the next question, the 9th question. Now here the details are the same of the question, that is annuity is 100, interest rate is 10% and the time period is 4 years, but the payment is made at the beginning of year, which means it is method called annuity due. Every time you make the payment at the beginning of each time period, it will be called as annuity due. Now here if you can look at the example, 100 is paid at the beginning of year, so interest will be received for the whole year. So all the 4 years the person or the investor will be getting 4 times interest, right? Because the payments are made at the end of time period, payments are made at the beginning of time period, and remember the payment of the last annuity and the maturity date of the investment is not clashing here. Therefore, even the last annuity payment will be receiving the interest payment or the interest added to the principal amount. Let's solve. Again, this is a simple way of solving instead of the formula. Now here we can do a table format. Here 4 years, annuity will remain the same, 100 for each year. Okay, and remember here again interest, it has to be always 1 plus interest rate. Okay, so 10% will always be converted into decimal format. So 1 plus 0.1. At the power of 1 is 1.1. At the power of 2 is 1.21. At the power of 3 is 1.331. And at the point 4, reason being I am going to get paid interest even in the 4th annuity. So it's going to be 1.464. Every time you're going to write the interest rate, the year is going to act as the power value. 1.1 to the power of 1 is 1.1. 1.1 to the power of 2 is 1.21. 1.1 to the power of 3 is 1.331. 1.1 to the power of 4 is 1.464. As I told, what is the 4th column? 4th column equals to annuity multiplied by interest rate. Annuity multiplied by interest rate. Now here annuity is your second column, so for better for you to remember, second column, that is annuity multiplied by the interest column, third column. So column 2 into column 3. So 100 into 1.1 will be 110. 100 into 1.21 is 121, and then 133, and then 146. So once you add up every future value of annuity, you will get 510 rupees in total. Now remember, when the payments were made at the end, we got an amount of 464. When the payments are made at the beginning, I'm getting 510 rupees. So which one is a better option? Payments made at the end or beginning? Of course, payments made at the beginning, because you'll get one more interest period that you can account to the whole of future value of annuity. Let's look at the 11th question now. Now this question has uneven cash flows, which each year the cash flows are different, 5, 10, 15, 20 and 25, and the payments are made at the end, which is annuity due. Payments made at the end, which is So question number 11, we have uneven cash flows and the payments are made at the end, which is ordinary annuity. And the time period is 5 years, interest rate at 10%. Let's solve it on the table format. Years are 1 to 5, and then we have annuity. Annuity amount is 5,000. Second year is 10,000. Third year is 15,000. Fourth year is 20,000. And then the last year goes 25,000. So interest rate, there is 1 plus I to the power of n. Here interest rate is 10%. To the power of 1 is 1.1, 1.21, 1.331, 1.464. Remember, since the payments are made at the end of time period, for the last annuity I will not be receiving interest. So therefore your interest column is going to be nil. So the last column is annuity multiplied by interest, that is 5,000 into 1 is into 1. Last one 25,000 into no interest, so you will directly have the amount, which amounts to 85,780 rupees. 85,780 rupees. The reason is the last year I am not going to get interest because payments are made at the end.